All right. Well, today is the day. I think I'm gonna be starting the project, biggest project I've ever built before. I think today's the starting point for that. But to get to the day started, I want to continue working through HackerRank problems, the easy problem set of the algorithms. And I believe we are, I think it just shows me automatically the next one I'm working on. Oh, these are, I haven't done these. Oh, unsolved. I have that checked. It's like, I've done these. Day of a programmer. All right, here we go. First problem, and I'll drop this in the chat and Discord channel. And go to Discord. All right, Marie invented a time machine and wants to test it by time traveling to visit Russia on the day of the programmer, the 256th day of the year. During a year in the inclusive range from 1700 to 2070 or 2700. From 1700 to 1917, Russia's official calendar was the Julian calendar. Since 1919, they used the Gregorian calendar system. The transition from the Julian to Gregorian calendar system occurred in 1918, when the next day after January 31st was February 14th. This means that in 1918, February 14th was the 32nd day of the year in Russia. In both calendar systems, February is the only month with a variable amount of days. It has 29 days during a leap year and 28 days during all other years. In the Julian calendar, leap years are divisible by 4. In the Gregorian calendar, leap years are either of the following: divisible by 400 or divisible by 4 and not divisible by 100. Given a year, y, find the date of the 256th day of that year according to the official calendar, the official Russian calendar, during that year. Then print it in the format of day, month, year, where DD is the 2-digit day, MM is the 2-digit month, and YYYY is the year. For example, if the year given was 1984, it is divisible by 4, so it is a leap year. The 256th day of a leap year after 1918 is September 12th. So the answer is 1209, 1984. It's a lot of info that they gave us. And I wonder if that's true. Did Russia change calendar systems? Huh. Hmm. Cool. We're gonna be working with date. I am not a big. I don't know a whole lot about date. There's a lot of different methods to get specific types of dates. Um, like there's all these, right? Um, hmm. Right now, I'm just trying to figure out the Julian. I don't know the difference between the two. Um, it seems though with this, hmm, can I don't know that the JavaScript date can do anything with days before it was invented. So let's test that real fast. So we have a console here. What did I want? Returns the day of the month. Yeah, it does. Okay. Interesting. Okay, so that's not a problem. It's just counting from this date here. Okay. Okay. So I think we have, I don't really need to know the day. I need to return um, well, how could I accurately say, so we have a couple of cases here, so let's write those out, right? We have Julian calendar, which is everything before 1918. Let's give it a day here. What was it? It was, so everything on or before this date, which we can just less than or equal to and what do we want to return? What aren't we just getting a year? 1984 is divisible by 4. Oh, and then we have to find this day. So if I'm given 1917, that's right. So we're trying to find the 256th day. So each year has one possible answer. And we just need to make sure we have that correct, right? So because the date, because date is using the Gregorian calendar, what that means is we still have to calculate whether or not it's a leap year, and then we need to convert it. This is just a comment here. We need to calculate any date to see if it is a leap year. And if it is, there's a difference of 1 day. Right? So once every 4 years. Given a year Y, calculate any date to see if it is a leap year. If it is, we add one. Um, what is the difference? Is it 14 days? Let's see what the 32nd day of 1919 is. I wonder if that changes. But, because I wonder if we also have to figure out 1918, if that's just a weird date, a weird year. Gregorian calendar. If the year is greater than 1918. We need to still run the same calculation, right? And the way we do this for the Julian calendar is specific. Okay. And Gregorian calendars, this is done by what is this? Years modulus 100. Yeah. So years, is there a remainder of, if I do years divided by 100, if the remainder is 0, then this is false. If it is not 0, then this is true. So years modulus 100, if that equals 0, then this is a false statement. And then leap years divisible by 4. Modulus 4. There's no remainder. So, so calculate if it's a leap year. If actually, I don't know that I need to calculate if it's a leap year because its date is already a Gregorian calendar thing. I should be able to just pass it the year, I think, and it should give me back everything else. If I just find the right, if I give it the day, let's see. Let's do this. How to use date.js to return get date like that. I don't think I'm doing this right. There isn't one that we can just chain. Or, I'm sorry. Alright, well, I'm sick of looking at that way. What if we do... Thanks, Zach. Appreciate that. Furthermore, they might be the least exciting thing to learn about. Uh, I agree with this. Time zones and formatting standards is just so confusing to me. Hmm, that's interesting. So what he's doing here is he's showing that he creates my date, and then he says, all right, I'm going to do to date string. It'll say Tuesday, September 29th, but my date to ISO string is actually the 30th. Hmm. On my local computer, the result of date to string was September 29th, while on my server, the result of date to string was Wednesday, September 30th. And furthermore, both computers return the same result for the to ISO string method. This is the last time you'll be confused by this. If we're going to learn this once and for all, we need to start by learning about a computer's time zone. Here's my local computer's time zone. Here is my server's time zone. I was wondering if his server was somewhere else. As you can see, the local computer's time zone is EST/EDT, while the server's time zone is UTC. This, along with some quirks of JavaScript, is why we got such an unexpected result. It was in a different time zone, so a different day has passed. While I agree JavaScript can be unnecessarily confusing sometimes, when it comes to date, the entire system is confusing, especially when we talk about time zones. With a little history lesson, I think we can get this to a manageable place. What is UTC? The key to understanding JavaScript dates. UTC stands for Coordinated Universal Time. Or is it Universal Time Coordinated? And per the name, it is the basis for how time is kept, kind of. Before we had a record of time on our wrists, in our pockets, on our walls, and on our overpriced coffee makers, People needed a reliable way to calculate the current time, and they did that by the sun. Warning, we're going to get distracted for a few minutes here, but if we really want to remember how these pesky JavaScript dates work, we need some historical context. If you don't care about my brief history lesson, skip ahead. Imagine sticking a perfectly vertical pole in the ground on a perfectly sunny day. When the sun rises, that pole is going to cast a shadow west, and conversely, it will cast a shadow east as the sun sets. Because the sun rises in the east, and it's going to cast a shadow to the west, and as the sun sets in the west, it's going to cast a shadow to the east. If you were to count how long it took for that shadow to move from point to point, you could kind of keep track of time. But there's a problem. If I put the vertical pole in the ground where I live in the US, the shadows aren't going to be cast in the same direction at the same time as someone else putting a pole in the ground somewhere in Ireland, right? So if someone puts a pole here and I put a pole here, as the sun rises in the east, be this way, yeah. No. Kind of. It's tilted. But as the sun rises, that shadow is going to be cast here first, and then eventually here. Actually, I think it gets cast here first, and then anyway. To solve this, we need a common point, or common reference point, and a standard time, a time standard. At some point, some scientific people thought that using 0 degrees longitude, the prime meridian, which happens to be Greenwich, UK, would be a good universal reference point to put that proverbial pole in the ground. You know, I think this is hilarious. We call this 0 degrees longitude prime meridian. This line, I mean, if we're truly a globe, this line could be anywhere, right? And we just move the map a little. But this is probably the most familiar map of the world, I think. Okay. Um, so we'll put the pole in the ground there. So everyone has a pole in the ground here, so to say. The next challenge is actually calculating time based on that pole in the ground. It used to be calculated using Greenwich Mean Time, the GMT standard, which started in 1847. But sometime in the early 1960s, some engineers decided that we needed a new standard and a more consistent calculation than GMT. In 1970, the UTC standard was finalized, but in 1972, an amendment was made to add leap seconds periodically in order to keep UTC in agreement with mean solar time, which is slightly imprecise due to the irregularity of Earth's rotation. Today, there are 3 main calculations of time, which is starting to mean less and less to me as I write this. Mean solar time, universally coordinated time, and international atomic time. I have to take this. All right. Just I have a sick kid and he's throwing up, so that's no fun. Um, all right. So let's continue on. So we have these three different. TAI is the most accurate and calculated by atomic clocks. UTC is derived from TAI but has leap seconds added to it for the sake of staying synchronized with UT1. In JavaScript, you'll see GMT a lot, but it's just a legacy term that never went away and can be thought of as the equivalent to UTC. Fun fact, the last leap second was added June 30th, 2015, and in 2023 at the World Radio Communication Conference, there'll be a discussion about possibly removing leap seconds from the UTC standard time standard, which hasn't been changed since 1972. That's cool. Everything revolves around UTC. Since 1972, the world has been operating based on this UTC standard, and it is considered plus minus zero when talking about time zones. So we have UTC here minus and plus. Hmm. It's interesting, these get to, I'm either plus 14 or negative 10. That's not equal. Um, yeah, it's funky. If we move west, each successive time zone becomes 1 hour more negative, while the opposite applies while traveling east. As you might have guessed, since the world is a sphere, moving east eventually gets you to a Western time zone. For example, the negative 10 time zone is equivalent to the 14 time zone. Time zones can be defined in two ways. And what about daylight savings time? We can talk about time zones in two ways. As a numerical reference to the 0 point, which is the UTC time zone, as commonly known as UTC or EST, as a commonly known name. So Eastern Standard Time. The one thing we have to remember is that UTC does not change ever. I live in the eastern part of the US, so from November 4th, 2019 to March 7th of 2020, I lived in the Eastern Standard Time Zone, or yeah, from the official time zone list. The EST time zone could also be referred to as UTC-05, -5, because it is 5 hours west of the UTC's time zone. But what happens on March 8th, 2020, the first day of daylight savings time in the US? If UTC never changes, then how the heck do we know it is daylight savings time? On March 8th, 2020, the first day of daylight saving times, my time zone changes from EST, Eastern Standard Time, to Eastern Daylight Time. I had no idea. So EDT can be referred to as UTC-04 because now we have sprung forward as a result of daylight savings time, and now I am only 4 hours behind UTC. That is so interesting. See how that works? UTC never changes, but the time zone you are living in does. Oh my gosh. Okay, because I've heard of Mountain Standard Time and Mountain Daylight Time, where I live, and I've always wondered. People have said, "Oh, there's no difference." There is. There is a difference. Those are different time zones, I think. Maybe. Now I'm not so sure, now that I'm saying that out loud. Let's see. Don't I have a clock thing? Grilled clock widgets? Sure. Oh, here we go. Oh, I thought it would be cooler than that, but let's see. What if I do? So we have Mountain Daylight Time. So it's an hour ahead. So what if I went to like Arizona? Mountain Standard Time. That is interesting. And the way they do this is really weird. They're doing +2 from where I am and not from UTC. Okay. Interesting. That's cool. So UTC never changes, but the time zone you are living in does. To most, this doesn't matter because when I say the event starts at 10 a.m. Eastern Standard Time, nobody's going to question me on whether I'm talking about EST or EDT. Nobody cares because our smartphones take care of the behind the scene conversations. That is 100% true. When I tell someone it's Mountain Daylight Time, they're not going MDT time. They're not Googling the time. But if they did, if I said Mountain Standard Time and they Googled the time, then this should be a different time, shouldn't it? Yeah, there we go. Google has it wrong. So Mountain Standard Time is 7:40. That is so interesting. So Mountain Standard Time is currently being observed by Phoenix. So this orange area. That is so interesting. This is really cool. But as JavaScript developers, we are the ones writing these conversations and therefore probably should understand this stuff. But my JavaScript date says GMT-0400. Remember, JavaScript is weird, and in its weirdness, it is still using GMT. But remember, this represents but does not calculate the dates. In your brain, when you see GMT, just think UTC. And when you see GMT-400, this is the same thing as UTC-04. JavaScript was invented in the 90s, so I'm not really sure why they didn't just use UTC rather than GMT, but that's a question for another day. But what about Unix Epoch? So let's get back to computers. Certainly you've heard of the term Unix Epoch, which was defined January 1st, 1970. If you haven't heard of Unix Epoch, just Google it. And there's a lot of info on Wikipedia about what that is, and how it was built. Basically, if I was to just give you a quick rundown, it's a moment of time that was defined that computers count from. to get our, a current date. Because a computer can count up or down from a specific time, but it can't really just, you know, like how does a computer have a reference point to where the sun is, right? It doesn't. It can't yet. So this is just a way to get, it's basically just counting from a specific point. Here is ISO 8601 format. More on this later. While the time engineers were hard at work defining UTC standards in the 1970s, computer engineers were also hard at work building computers. When you build a computer, you have to give it a reference point and a tick frequency in order for it to remember what time it is. And that reference point was arbitrarily chosen as midnight, January 1st, 1970. Several sources debate the true reason behind this date, but in the end, it doesn't matter. It is a reference point. That is the reference point. Feel free to leave your theories or stories in the comments if I'd love to read them. So what is JavaScript? What is a JavaScript date? A JavaScript date is the number of milliseconds that have passed since midnight on January 1st, 1970 UTC time zone. That date sounds familiar. When working with JavaScript dates, you must always remember this definition. There are plenty of prototype functions on the date object, such as getDate, getUTCDate, get and to ISO string. But there is only one method that gives you a true representation of a JavaScript date. The value of method tells us that so this is it's just a number, right? How long, how far. The value of method tells us that midnight, January 1st, 2020, UTC time zone is so many milliseconds after midnight, January 1st, 1970, UTC time zone. And if you're like me, you probably are wondering about the 0.0. So yeah, here's milliseconds equal how many years. You're wondering about the 0.032876712 part. This represents leap years. Since 1970, we've had leap years in the following years. So every 4 years, right? Or, yeah. Since we are using January 1st, 2020, and the extra day gets added in February, we need to exclude 2020 leap year in the calculation, which gives us 12 total leap years since January 1970. And if we convert years to days, that's how we get those extra decimals. If we wanted to calculate a date before, is that possible? Of course, we're just counting, and this is what I meant earlier by we're just counting down. Possible date object values, possible date object output values. When we print value of the date above, you might have noticed that the output was a number. This is the first of 3 possible outputs of a date object: a primitive value of date object, which is just that number, an ISO 8601, which is a string, a specific looking kind, JavaScript standard format string. And here are the examples, this, and the much more readable version than that. Value of toISO string and toString. The primitive value of JavaScript date is straightforward. As we discussed, it represents the number of milliseconds since midnight, which is a number value. But the ISO 8601 format is a bit more confusing. But once you break out the pieces, it doesn't look so intimidating. ISO 8601 actually has nothing to do with JavaScript. It's a global standard for times and dates. More on this in appendix later. Year, month, date, time indicator, so hour, minute, seconds, time zone indicator. JavaScript ISO 8601 format. We'll talk a little more about this format later, but for now, just remember that T is the indicator for time, while Z is the indicator of time zone. In this case, Z comes from Zulu time, which is a military time zone reference for UTC's time zone. So Z, Zulu time, military is equal to UTC time. Every time you use to ISO, you will always get a UTC representation of the date indicated by Z. Last but not least, in my opinion, this is the most confusing output of them all. The primitive value prints the number of milliseconds each this guy. The primitive value prints the number of milliseconds since epoch, which is easy to grasp. The ISO 8601 value prints the date value represented in standardized format that never changes. The JavaScript standard format, it not only prints out a time zone that we still haven't talked a lot about, but it also produces unexpected results as shown above. September 30th input changed to September 29th output. Let's solve this JavaScript mystery once and for all. A tale of two computers and why they can't seem to agree on what date it is. At the beginning of this post, before we knew anything about UTC, I showed an example of how JavaScript dates can appear different depending on what computer you are using, and of course the time zone that computer is in. In this section, we are going to be using two computers and a single date, September 30th, 2020, the day of writing, to demonstrate exactly why your date is off by 1. Here are two different computers with different time zones as shown in the screenshot below. Notice how the time zones printed look a bit different than the time zones that we talked about earlier. That is because there are two official time zone lists, a regular one and a computered one. In the first part of the post, we used a regular list, and let's take a look here. This is my local, this is my web server. The time zone is America, New York. This is ETC, UTC. So remember, while we're using the computer list, local time zone is EST, and the web server is at UTC time zone. These two computers have different time zones. So we passed the value and got the same output. Because the date, I don't understand how these are the same value. So if I did this, if I go to here, wait, he's running new date dot value of, right? Just try that here for a second. I'll just copy what he has here. What if we just do this, right? And then we say D. So if I run this again, see time's elapsed, obviously, since I did this to this one, right? But I guess the problem, I guess I was thinking in my head, wait, if he's doing these at the exact same time, the exact same second, right? Then they both, so they both have the same date. So they're not asking for the current time. Yeah, they're not asking for the current time, right? He's not saying new date invoked. He's saying new date at this specific date. They should both have the same difference of time from this January 1st, 1970. Okay, cool. And then, of course, UTC, we should have, so two UTC string will give us the same time from that date as well. Let's look at the ISO string, which should be the same thing. And it is, which makes sense. But when we say toString, okay. And this is why, yeah, and toString has a different time, right? And this is, so because this one's going to calculate -4 from that specific date, right? Is what I'm thinking. I haven't read ahead yet. So this is what he has when he does toString fed this exact date. It makes sense that this value would be the same because it's how many seconds from an arbitrary date to this date. And that's going to be the same no matter where I am, right? Because it's the same exact point in time. UTC is, UTC I kind of expect actually to be the same. ISO, yeah. How does ISO? That's interesting. Yeah, interesting. I'm not quite, I'm interested in the example now. Oh, here we go. I'm a little bit, let's think through this. We know the following things. We used an input value of 2020, September 30th. The primary value of the JavaScript date is the primitive value of the JavaScript date is this many seconds since this time. If we convert the primitive value to UTC, it represents midnight, September 30th, 2020. So what we can conclude here is that some of the JavaScript date methods output the true value of the internally stored date, while other methods output the relative value of the internal stored date based on the time zone of the computer that is printing the value. Remember, the computer on the left is EDT, while the one which is UTC -4. So if the internal value is this, and we convert this to an EDT, we have subtracted 4 hours. If we subtract 4 hours starting at midnight, then the relative time zone date is 8 p.m. Okay, I get it, but why does JavaScript do it this way? So here's how JavaScript dates work. If you entered a value such as this, JavaScript's assuming that this value is UTC time. JavaScript stores it as UTC time. JavaScript outputs it in your local time when using toString method when you console.log the date. The real question is, if JavaScript assumes you are inputting a UTC value, why does it not assume you want a UTC value outputted? Well, in JavaScript's eyes, when you typed 2019 or 2000 September, you weren't specific enough. So let's talk about how to avoid this problem. How to think about JavaScript dates. When working with JavaScript dates, we need to ask ourselves the following questions. What was my input value, and how did I specify a time zone? So this versus this. What is my UTC value of my date? You can always find this using toISOstring. What JavaScript method am I using to display the date, and what time zone will it output my value as? So let's say you're building an app that allows a user to specify their birthday on the user file. Imagine that our user's birthday is on June 28th, 1970, and they live in Florida. If you code up an app real fast and ask the user for his or her birthday, the incorrect way to show date in JavaScript. The user has selected June 28th, but your web app is showing June 27th when printed as a string. Here's the code for that web app. Let's see if you can spot the mistake. Let's go through our checklist from earlier. What is the input value, and did I specify a time zone? By default, the HTML5 input is going to record the date in UTC. So technically, without specifying a time zone, but is the default UTC. What is the UTC value of this date? If you were to print console.log date value to ISOstring, you'd get 1970, which represents the UTC value. Oh, right. So Zulu is UTC, or like the prime meridian, right? Greenwich. So what JavaScript method am I using to display the date? This is where I went wrong. Our input value was recorded in UTC, but since we used the get date, get month, and get full year methods, we will convert the raw data into the user's local time zone, which is Eastern Standard Time Zone. How do we fix this? Two methods. Easiest, display the date in UTC time, consistent with how it was input. Harder, ask the user their time zone and specify what time zone when you save the date. The first method, all you need to do is change this, right? Day, get month +1, get full year, and change it to this. Get UTC date, date value, get UTC month, get UTC full year. And that will make it, because UTC, and I think the others that we had, I mean, obviously you don't want to display this in the primitive value. So the ISO, oh, we had another one. We had 4, didn't we? Yeah, to UTC string. And then toString is calculating the relative value of the, yeah. After these changes, it works. The second method is more complicated, but it could still work. Let's just say if you ask the user to select their time zone, they entered EDT time zone. Once you have this information, you could use the following JavaScript code, although I don't recommend. As you can see, there are more lines of codes, a bit more repetitive. Definitely not recommended. The example in the previous selection highlights a specific gotcha scenario, but there are many other ways to work JavaScript dates. For example, you can pass pretty much anything into a date. Remember to pay attention to your input values. In example 1 through 4, we are specifying these dates in UTC time because that's the default, right? Unless we specify otherwise. In the examples 1 through 4, examples 5 through 6 are the only cases where we are specifying the dates according to a specific time zone. So we are giving it more data, right? In example 5, we are doing so explicitly. In example 6, static method will automatically calculate the current date and time in your computer's local time zone. This method returns a native date value, the number of milliseconds since midnight. So we need to pass that into the date constructor to get an actual date object. In other words, if you're planning a live stream event that is happening in California, remember this is during daylight savings time, at 8 p.m., then you need to input it as where PDT, Pacific Daylight Time. This will ensure that whoever reads this from their personal computer in a different time zone will have this live stream event time and date displayed on their local time. Feel free to try it out yourself. The output of my event to string should print the time and date of the event converted to your time zone. There's got to be an easier way to do this. No, you're stuck with vanilla date object. There are libraries, Moment and Luxon, that give quick and easy methods to create and format dates. That said, I recommend a full and thorough read of this post at least once or twice before using these libraries because although they have lots of helper methods to work with them, they do not change how they work internally. So basically, get your mind around the basics and then move forward. So this is the extended variation. Hmm. If you want to read more, like here's more things I've written. This is a great post. Should have probably shared this a bit. That really cleared up dates for me in JavaScript. It's been one of those things that I'm like, I have to read this because I keep encountering it, but um, Awesome. So that that was good. Still haven't solved the problem, obviously, and we still have some work to do. But I think we have a good understanding now that we could say that this point in time, if we think of that Unix epoch, is going to be so many seconds from, or to or from, and if we do date and pass it a specific um, I want to know how many days. Find the date, 256th day of the year. 256th day. So I wonder if I can use date. If I gave, let's mess around here for just a second. If I said new, well, if I said new date, and I fed it a arbitrary year, let's say 19, or yeah, sure, 1899. Okay. See, and it automatically, this is the the time zone I'm in currently. So it calculated it per the time zone. So if I say um, so that would give me, because this is calculating minus, whatever. Um, um, all right. Let's see here. Wait. 256. That added years. How do I add days? Hmm. I don't know. How to add days to a date. We should probably make JavaScript. If I'm get date. Set date. What does set date do? Changes the day of the month to a given date instance. So instead, change the day of the month for a given date. Based on UTC time, use set UTC date. So we have a new date, passing it this. I'm going to get rid of all this stuff here. And I want to set the date um, how about to UTC string? That's what it was. Hmm. Um, oh, an integer representing the day of the month. That makes more sense. So I don't, yeah, this is kind of where my mind was going. I could get the value of and just add milliseconds. And get a precise number, I think. That should work, right? So if I said, so how many milliseconds are in a day? So we got 24 hours times 60 minutes, and every minute is 60 seconds. Right? Yeah, 24 hours. Every hour has 60 minutes. Every minute has 60 seconds. So this should be well, that math is off. About a day. All right, so that's how many milliseconds are in a day. So if I said, all right, so if I said new date 19 or like 1799, and I said value of plus, and I wanted to add, what was it, 256? What's the problem? 256, yeah. Times, hey, and then we could just say dot to, let's do isostring. How do we convert that back into, hmm. How to convert a primitive date value into a object, into a date. Yes, but flipped. I want to flip this. Like if I did, wait, shouldn't this be a negative number? Wait a second. um, Wait a second. I thought this was supposed to give me the where's value of, yeah. Hmm. All right, let's go. Let's try this again. Hmm. Oh, that's funny. That's why, because if I said a dot UTC date, this is going to give me 1. Yeah, because this is calculating what time zone I'm in. All right. I'm getting it. I'm getting it. What I'm not getting is I thought this would give me back. What if I said a dot get, what is it called? Interesting. It gives it a specific date. All right. Well, I'm going to be right back. All right, so, whoops, that's a little close to my face. Sorry about that. I promise that whole time I wasn't in the bathroom. Last about 30 minutes, I was to talking to a business about a job opportunity. So, phone interview. It's just nice. That was pretty cool. Awesome. So let's continue on. Um, I am trying to remember my last train of thought. I think I was trying to count up from a given time period. So if we gave a date, and I think we were doing this, if we inspect the page, can I clear that? Let's do Command L. There we go. Control L. So if we say d equals new date and we pass this a year, but if we say new date, passed it a year, year, a day, yeah, that's how we get it. But why can't we get, could we chain new date 1888 and say to date, not ISO, UTC string invoke dot value of. So we pass this to, how about ISO? Why is this? All right, let's oh, it's still too close to my face. Let's go check out this article again. There was a part if you pass it a string date, I wonder if that is. If it was a string. Hey, that was the problem. And why I didn't notice this before, but this kept giving me back the Unix Epoch date. All right. Okay, so I believe what we were doing is we were saying, please tell me you give it as a string. It's giving me an integer, so we'll stringify it. So if we say, oh no, what was the, there we go. All right, so what we were gonna do is we're gonna do this, put this in a string. We're gonna this situation, we would subtract the result of 256 times and then we would say dot to UTC string. Actually, yeah, no, we'll do UTC. Let's do the same number here, actually. Cool. How do we change this to a oh wait, wouldn't this always be added though? I think this always needs to be added because this is always going to be the beginning of the year. So as time moves forward, the gap closes, right? Yeah. Oh, we can just pass it into the date? Oh. Oh. So I could just literally say oh, that's not what I want. Wait, new date. I'm gonna put it in B dot get. What did we want? Day? Wait. Oh, this is missing some zeros, I think, because I was like, that is not correct. Isn't it like 86? No, there's 4 zeros. Wait a second, what? Five. Yeah, it was off. All right, cool. What is date? What is that supposed to be? Um, August. All right, that's it. We're just gonna say new date. What does that give us? So what is the 4? Sunday, Monday, Tuesday, Wednesday, maybe? Hmm. Oh, and the months are 0 through 11. So this is September. September 13th. All right. So let's just do let's run that code. All right, so this is a number. So first and foremost, that needs to be a string. Wait, isn't there an easier way to do that with a number? Parse int can change a string to an integer. Number, string to a number. Interesting. About the other way around. Oh, might help if I have two string. Gotcha. Stringifies for our arrays, two string. Okay, and we'll just double check, make sure that works the way we are thinking it is. The year. Yeah, cool. It's a string. So now, if we say new date and we pass it the year, we can save this as I'm glad I saved that number. All right. So we're given a year, and we can calculate time this way. What if we say and we say date dot get is year one of them? I assume it is. I guess we'll find out. Could have sworn get UTC date was the function. Hmm. Why is it 13? um, hmm. So we get the correct year. So this would be September. September. Hmm. About get date. How come these functions aren't working? How about we do this? How about now? Do you like it now? Hmm. Hmm. Well, let's check a few things. All right, let's check those. This is the year. This is the UTC of the year. This is the Unix Epoch of the year. Okay. I think what I'm doing wrong here is the Unix Epoch goes in a new date, like this. Yeah, that's what I was doing wrong. And so what we would say is and then we would say console Oh wait, yeah, month has to be, why did I put month here? Month has to be +1 as well. Um, oh, that's Thursday. Yeah, I don't want day, I want. Wait, isn't get date? Shouldn't this be relative and I'm behind UTC? All right. I knew I was gonna have to face this. Because why am I subtracting 1 from this, you know? Why is this is an interesting problem. Why is, they gave me the year 1800, and this is the UTC of that year. We count 256 milliseconds. Closer. But somehow we land off by 2 days. What's the year? Yeah, that doesn't make sense. I want to see how many test cases it passes, though. Oh. What? 5 out of 61 failed. Interesting. Wonder if all of these are above the year. Let's check one of them. Yeah, I bet you all those are above. $19.18 is 14. Was that 14 days? If year is less than 1918, then we're going to return this, except it's going to be -2. Else, if year is equal to 1918, we're going to give this a shot. +14. Else, we're going to do this. We'll put returns in front of all of you. I think that is about right. There we go. Let's see if it passes all those test cases. Is it the same? They're different. Failed even more. Huh. We'll comment this out and run this again. That's really crazy. I do have console logs. What the heck? Fine. We'll do this. Won't let me see my own code. Control L to clear. Awesome. Day of the programmer, and let's feed it the year 1800. So we have the 13th. Is what we're getting back. So this was our original. And I bet you this will solve that problem. And create a new problem. Awesome. So that does solve that problem. Let's see if it solves 1918. So that's the 13th. Should be the 26th. Oh, it's the 28th. So I was 2 off. So that needs to be 12. Well, let's try that first. And there should be a lot more going on with that, but about, oh, there we go. Okay, cool. So that does solve that specific case, but then it breaks a bunch of others. So if I do else if, that should still break. $19.17. Why are we All right, all right. Let's go back to all right. So this solution right here, I disagree. I think the UTC date should be right? Whatever the Gregorian calendar is, right? So and this is the best. We just get 5 wrong. 1700, 1800, 1900, 1918, and 1800. Is 1800 on there twice? It is. That's so weird. All right. um, what was it? We're gonna pass it 1700. We're getting 13, and it should be 12. About 1800. We're getting 13, and let me guess, it should be 12. Seeing a pattern. Yep. 12, 26, and 12. So what if we do this? If year is less than 1918, we'll do that. Run a test run. programmers are 18. Should be like our, it's this, but plus 12. All right, oh, that's gonna fail. There we go. Try that again. All right. See if that does it. More errors than before. Phew. That is super weird. All right, well, let's do this guy then. Wait, let me just Control L. Okay, so day of the programmer at 1700 should be 12. What? Well, that's confusing. Wonder if HackerRank's having some problems. Let's copy that. Cool. Let's refresh maybe. Okay, cool. Super weird. I am really weirded out right now. It's like it was running and now it's not. I can't even get my like console logs. If I inspect the page, do year, okay. Let's try our code. And we'll comment this one out this time. Comment these in. So day of programmer, we're going to pass out 2. We're going to pass this 1800. Oh, that's right. That needs to be a 2. Let's see if this works first, and then we can try it again. this is weird. Hmm. Okay then. Was I typing it in wrong? Well, that I definitely typed in wrong. Did I define it something else? Grammar. Nope. Okay. Whatever. Cool. I think we got it. So this will work. Excuse me. All right. So let's go ahead and do it. Now I'm curious if that's the case with all of those. The same 5 cases. They're all a month off. And do we have the... Oh. Nice. There we go. Well, that would make sense, wouldn't it? Same 5 cases, though? Or is it just 1800? 2 cases. 1918 and 1917. Yeah, I think this is supposed to be 1918 actually. In 1917, yeah, should be resolved. Hey! That's what I'm talking about. All right, now we can simplify this because we notice that all of this is the same before, except of course this guy. So if we said year is let's cut all of you out. If year is less than 1918, this should work the same. But it doesn't? What? There's some weirdness going on with this. So much weirdness. Actually, 56 of the test cases. Yeah, you would think, right? But these are all before as well. It's so weird. All right. So I'm going to copy this. I kind of want to play with that just a bit more. See if we can't figure it out. All right. So we just need to how do we clear history? All right, we'll just do this. Go to a different page. Perfect. If the year is less than 1918. Awesome. All right, so then we can go back. Was it 1917? $1916. Let's go back to 1916. Okay, that brings 12 like it should. Whoa. Oh my gosh. You know I have to minus 1? I didn't even realize this. Where am I doing that? I'm not grabbing the UTC of the date here. Ah, that makes so much more sense. Why I have to subtract 1. Alright, so if I did yeah, so all of this is in my time zone. Minus 7 to where I am. So it's a day behind. Hmm. Hmm. What's so weird is that -1 would be right. Because this is the current. No, 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 no. -1 would be wrong. We need to go up 1. What if we. But that's gonna break. Why is that only true for some of these? So if I went back and grabbed this function here, well, specifically this kind of if statement here, went back over here, comma out this block, did this, and we make this day like that, it's going to break some of our tests, right? Yep. So Is that reason? So it's probably has to do with the Julian calendar. Oh, it does have to do with the Julian calendar. The doy. About that. Wait, I have that flipped. Huh. There we go. I think that's it. The only problem is this is going to pull in years after as well, which are fine. So if year is less than or equal to, we'll just say less than 1918. There we go. What? Dang it. What are we looking at here? $19.16. Isn't there a zero remainder on that? Yeah. $18. 18 and 19, these all should have been 12. I'm currently getting 13. Why? Why is that the case? It's almost like this should be okay, 1700s, 1800s, 1900s, and 19. So these three, are these? Yeah, they're modulus 4. So should we be subtracting 2? That is so weird. There is a lot of weirdness going on here. The only 4 that passes. That is so weird. All right, well, I'm going to wrap that up. I've learned a lot about date. I feel like I understand date quite a bit. I don't think I solved this the way they would want me to solve it, but I had fun. It was great. Again, learned a ton about date. Spent quite a bit of time on this, but that's okay. I'm okay with spending time on stuff and learning new things. I'll go ahead and share that here. And also, I'm going to share that link too. Awesome. Very cool. I am going to go take a break, and then what do I got for today? Got a few meetings. Got all these text conversations here. Okay, so I got a meeting at 1 and 3, so yeah, it's kind of an awkward time, but maybe I'll just move my lunch now. And then I will work for, I don't know, maybe I'll do some, I think what I'll do is I'll eat some lunch, I'll hop back on and do some like HackerRank issues for SQL or something new, something different than algorithms.